Are you interested in the latest space news? Wait no further and do not forget to like and subscribe to my channel. Now let's look at what's trending right now. Astronomers may be interpreting James Webb Space Telescope's measurements of exoplanet atmospheres wrong, a new study suggests. The James Webb Space Telescope, the most complex space observatory ever built, captures stunning images of the most distant reaches of the universe. It also takes measurements of the chemical compositions of the intriguing stars, galaxies, and nebulas it sees. To interpret this data, scientists rely on complex models. But a new study by researchers from the Massachusetts Institute of Technology found that these models are not accurate enough to capture the nuances of Webb's observations. The relative crudeness of these models, the scientists said in a statement, might mean that the analysis of atmospheres of distant exoplanets could be off by an order of magnitude. There is a scientifically significant difference between a compound like water being present at 5% versus 25%, which current models cannot differentiate, Julian DeWitt, an assistant professor at MIT's Department of Earth, Atmospheric, and Planetary Sciences and a co-leader of the study, said in the statement. The models in question analyze the opacity of the material observed by Webb, a measurement of how much light passes through it or gets absorbed, and at which wavelengths this occurs. Since every chemical element absorbs light differently, astronomers can reconstruct the chemical compositions and ratios of these chemicals in great detail using these measurements. Webb, although built to observe the oldest stars and galaxies in the universe, has already proven its strengths in studying planets orbiting stars in our galaxy, the Milky Way. The telescope detected important molecules such as water and carbon dioxide in some planetary atmospheres, but also took a direct image of a gas giant exoplanet. Astronomers are excited about Webb's ability to study exoplanets in such detail, because the chemical compositions of the planetary atmospheres they hope to find could offer hints about the possible presence of life on some of these distant worlds. But inaccurate readings of the data would mean the obtained insights would be quite unreliable. Our translation process will prevent us from catching important subtleties, such as those making the difference between a planet being habitable or not, DeWitt said. The researchers came to the conclusion by testing several versions of the existing opacity models and feeding them synthetic light spectra simulating those obtained by the James Webb Space Telescope. They found that various versions of the model produced differing values that demonstrated their accuracy limits, they said. The models, the researchers said in the statement, won't be sensitive enough to tell whether a planet has an atmospheric temperature of 300 Kelvin or 600 Kelvin or whether a certain gas takes up 5% or 25% of an atmospheric layer. That difference matters in order for us to constrain planetary formation mechanisms and reliably identify biosignatures, Prajval Niroyla, a graduate student at EAPS and co-author of the new paper, said in the statement. Currently, the model we use to decrypt spectral information is not up to par with the precision and quality of data we have from the James Webb Telescope. We need to up our game and tackle the opacity problem. The researchers also proposed possible improvements such as taking more laboratory measurements to validate the light-absorbing behavior of various chemical compounds and improving theoretical calculations. There is so much that could be done if we knew perfectly how light and matter interact, Niroyla said. We know that well enough around the Earth's conditions, but as soon as we move to different types of atmospheres, things change, and that's a lot of data, with increasing quality, that we risk misinterpreting. James Webb has spotted a strange alien planet with sand-filled clouds. The exoplanet, which is a brown dwarf, was initially discovered in 2016. It's known as VHS 1256b and orbits two small red dwarf stars. Astronomers were puzzled over the exoplanet's strange reddish glow, but James Webb gave them a better view of the stellar discovery. Brown dwarfs are intriguing stellar objects. These planets aren't big enough to turn into stars, but they're just too big to be regular planets. Additionally, brown dwarfs can produce their own heat and light by burning deuterium. Astronomers believe that the reddish glow the planet has become so well known for is caused by something in its atmosphere. This belief appears to have been confirmed thanks to observations made by the James Webb Space Telescope. By looking at the brown dwarf, astronomers were able to detect thick clouds of sand-like silicate grains. The Space Telescope also picked up traces of water, carbon monoxide, carbon dioxide, methane, sodium, and potassium. Astronomers looking at the data published their findings on the AR-14 servers. The paper has yet to be published and hasn't been peer-reviewed yet. They say that the brown dwarf James Webb observed is still small for that type of planet. This most likely means that the planet is still young. Scientists discovered it back in 2016, as noted above. It was found around 72 light-years away from Earth. This isn't the first time Webb has detected water on an exoplanet. It isn't even the first time Webb has detected carbon dioxide. NASA's newest space-based observatory has been very busy since it began science missions in July. Those missions began with the first full-color James Webb images. Those gave us an unprecedented look at the early universe. James Webb's observations of this brown dwarf could help us better understand these strange planets. More research will need to be done, especially with all the data James Webb can capture. But we'll hopefully see more studies on these types of planets in the future. If you have enjoyed, do not forget to like and subscribe.